Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into the Week 5 revision video. We just did revision in Week 5, so let's go over what we've learned this year. So we first look at equation of tangents. We actually learned that last year. The equation of the tangent to any curve is of the form y equals mx plus b because the tangent is a straight line. So when you're finding the equation of a straight line, you just need to find m and find b. Now, m, the gradient of the tangent, is the first derivative. Every time you differentiate a function, you are finding its gradient function. You're finding a function from which you can calculate the gradient of the curve at any point. So for this function here, the first derivative, or the derivative of sine x, is cos x, the derivative of minus x is minus 1, and whenever we're differentiating, constants like this vanish. So we need to know what the value of the derivative is at the point where this hits the x-axis. Now, if you don't know where this hits the x-axis, use your graphics calculator. You graph it in the y equals menu, then you go second, trace, and then you go to the second option, which is 0. The zeros of a function are its roots or where it hits the x-axis. So using that function, we should find that this function hits the x-axis at this point 1.934570. This is like very close to where it hits the x-axis. It's okay if your graphics calculator gave you a slightly different answer. It should be very close to 1.93. So the gradient of this function at this point, I just substitute the x value into here. So when I put this value into this equation, get y dash, the gradient is about minus 1.355. So now what I have to do is find b. So what I do is I take my equation y equals mx plus b, and I'm going to change m to this number here, and I change x and y to the coordinates of the point. So then I find b easily. I'm just going to get this number and add it to this side, and I get b is about 2.6229. So there I have it. I found the equation of the tangent is y equals m times x plus b, the y-intercept. That's how you find the equation of the tangent. All right, let's now move on to kinematics. So kinematics questions involve displacement, velocity, and acceleration. We did this last year as well. Velocity is the derivative of displacement. Acceleration is the derivative of velocity. To go displacement to velocity, you differentiate. Velocity to acceleration, you differentiate. So if I'm given a function like this and told it's the height of the ball, if I differentiate it, this will give me information about the velocity. So the derivative here is 19.6 minus 9.8 t. So this is my velocity function. So if I want to know the velocity after 0 seconds, that's the initial velocity, I just sub in t equals 0 because it says here that t is the number of seconds. So I would get 19.6. Now because x is in meters and t is in seconds, it's meters per second. If I want to know the velocity after 2 seconds, I just substitute t for 0. In that case, I get 0 meters per second. And if I want to know the velocity after 4 seconds, I substitute in t equals 4, I get minus 19.6 meters per second. So positive velocity means the ball is going up at 0 meters per second. 0 velocity means the ball stops, and negative velocity means it's coming back down. This is a ball traveling in a straight line. So the maximum height of the ball will occur when the first derivative of the height, velocity, equals 0. So the maximum height of the ball occurs after 2 seconds. So to find the height after 2 seconds, all I do is substitute t for 2 into my original equation up here. I actually get 19.6 again. So the maximum height of the ball is 19.6 meters. So this was all about velocity. Just so you know, if I wanted to find the acceleration, I would differentiate this function here. So if I differentiate the velocity, I get minus 9.8, and that is the acceleration. Acceleration is in like meters per second squared. So negative acceleration means that the ball or the object is slowing down. Positive acceleration means that it's speeding up. All right, let's now move on to some rules for differentiation. So this is the formula for the chain rule. It's also called function of a function rule because it's when you have a function like cos and then another function of x. So this is the rule you can use, but by now we probably use shortcuts. So to use the chain rule on a polynomial, all we do to differentiate is move the power to the front, decrease the power by 1. That hasn't changed. But what we need to do differently is times by the derivative of what's inside the bracket. So the derivative of x squared minus 4 is 2x. And of course, 10 times 2x is just 20x. So this is the derivative of the first one, the shortcut method. All right, to differentiate an exponential, e to the power of something, you always leave the e and the power alone. But the chain rule means you multiply by the derivative of the power out the front. So the derivative of this, derivative of minus 2x is minus 2. That's why I put it out the front. I left the e, left the power alone. So when we want to differentiate this function here, so remember the derivative of cos is minus sign. So what we do is we change the cos to a minus sign and we keep what's in the brackets. We don't change that. But the chain rule means that I have to multiply by the derivative of what's in the brackets. So the derivative of 1 minus x is minus 1. So that just becomes sine of 1 minus x, and we're done. Let's move on to the product rule. So this is the product rule up here. It's called product rule because it's when you have one function u and one function y multiplied together, the product of two functions. So the rule says to differentiate the product of two functions, derivative of the first times the second plus the first times the derivative of the second. So we would use it on something like this. This would take forever to expand, so we're going to use the product rule. This is my u, my first function, and this is my second function. So this is how we differentiate it. We do derivative of the first, so that is the chain rule, x plus 2 decrease the power by 1. So this is the derivative of x plus 2 cubed. So that's u dash. We multiply it by v, and then we add u, the first, times the derivative of the second. The derivative of x minus 3 is just 1. So sometimes you will need to factorize this. We have this term here and this term here. They both have a common factor of x plus 2 squared. So we take that out the front. So what do I need to multiply by this to get to this? Well, I need to multiply by a 3 and an x minus 3. What do I need to multiply by this to get this here? Well, I need to multiply by another x plus 2. Okay, and then just simplifying what's in the brackets. So we have x plus 2 squared outside of, so we have 3x plus x is 4x. 3 times minus 3 minus 9 plus 2 is minus 7. So this is the final answer. It's simplified as much as possible. Let's now look at the quotient rule. So we're now going to look at the quotient rule, which is what we use when we have a function divided by another function. So the rule is you differentiate the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So we'd use the quotient rule for something like this, where we have a function divided by another function. So for the derivative, it would be the derivative of the top times the bottom, and it's always minus for the quotient rule, so minus the top times the derivative of the bottom. So the derivative of cos is minus sine. So of course here we have two minuses, they would now make a plus. And then what goes on the bottom is the original bottom squared. So cos of x all squared, we usually write cos squared x. So I can factorize the top. I'm going to take out a common factor of e to the 2x. So then I'm left with 2 cos x plus sine x. So always look if you can factorize the top. And I'm going to leave the bottom alone now. Now sometimes after you factorized, you'll be able to cancel something on the top with something on the bottom. Now I can't cancel here. I can't cancel the 2 coses because the cos is being added to the sine. You can only cancel when something is being multiplied. So sometimes you'd be able to simplify the expression even further. Here we can't. This is our final answer. All right, let's now move on to graphing. So let's say I'm asked to graph a function like this. I need to do 4 things so I can draw its graph. Find the y-intercept and x-intercept. You can let your graphics calculator do the work and help you with these two, but you need to be able to find stationary points and inflection points by hand. So I've already done this for you. So to find the stationary points, I would differentiate this function and find where the first derivative is equal to 0. Turns out first derivative equals 0 at x equals 3 and minus 5 over 3. So after you've found the stationary points, we need to find the second derivative. So the second derivative tells us, firstly, are the turning points maximum or a minimum, and it also allows us to find inflection points. So the second derivative is actually negative at a maximum, and the second derivative is positive at a minimum. That's the second derivative test. You substitute the x values of your stationary points into the second derivative. If it's positive, the turning point is a minimum. If it's negative, the turning point is a maximum. So here we have a function that's concave down, and then suddenly it's concave up. So there must be a change in concavity, and it turns out the change in concavity here is called an inflection point. Inflection points occur when the second derivative is equal to 0. So it turns out the inflection point of this graph occurs when x equals 2/3, y equals 25.4. Note, this is not a stationary point. So this is a non-stationary point of inflection. A stationary point of inflection looks like this. It's both a stationary point and an inflection point, changing concavity from going concave down to concave up. So all of these things need to be calculated by hand when you're graphing. So practice on this one here, see if you get the same answers I did. All right, let's move to our final topic of optimization. So optimization always involves finding a maximum or minimum value of a function. So here we're asked to find the minimum surface area of a rectangular box with square base, no top, that holds 300 mils of liquid. So here we're not given a function to differentiate, so we need to first come up with the function. So if we let the base be x, we need to come up with an expression for the height h in terms of x. We don't know how to differentiate a function that has 2 pronumerals. We only know how to differentiate it if it has 1 pronumeral. So if the volume is 300 mils, which is 300 centimeters cubed, then the height is just the volume divide the area of the base. The area of this base is a square. It's just x squared. So here, h is just volume divided by area of the base. So now we're going to find a function for the surface area of this shape here. So the total surface area will have the area of the bottom, which is x squared. Remember, there's no top, as it said in the question. And then there's 4 of these rectangles. So each of those 4 rectangles has a width of x, so like this one here, width of x, and its height is 300 over x squared. So we times that by 300 over x squared. Now we have a function with just 1 pronumeral that tells us about the surface area. If we want to find the minimum of something, same as if we want to find the maximum of something, we differentiate the function and find where it equals 0. So making this a little easier to work with, 4 times 300 is 1200, x over x squared is x to the power of minus 1. So what I'm going to do now is I'm going to differentiate the surface area. I get 2x minus 1200 x to the minus 2. I now need to find where this is equal to 0. So to get rid of the minus 2, because that's going to mess me up, I'm going to times by x squared. I want it to equal 0, so times 2x by x squared. And if I times this by x squared, x to the minus 2 times x squared is x to the power of 0, which is just 1. So I get 2x cubed minus 1200. So you can use the polynomial solver on your graphics calculator to solve this if you want. You get x is approximately 8.43. So substituting back into this formula here, we get that the minimum possible surface area is around 213.4, and because we talked about mils, which is centimeters cubed, this will be in centimeters squared. So whenever you're given an optimization question to find a minimum or a maximum, you need to find a function, differentiate, and find where it equals 0. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Keep your head up. You're going to do so well next week, and have a great day.